All right, hello everybody. This video is about finding the domain of combined functions. So first we're going to talk about what the notation kind of looks like, and then I'm going to give you a couple things to remember when you're looking for the domain. So first, you can find the sum, difference, and product and quotient of functions by combining them. That looks something like this. All right, so here we have the sum. What this means is that we have the f plus the g, and that both f and g are functions that depend on x. F plus g, where both f and g depend on x. Now this f plus g might not be the way that you're used to seeing it written. You can also write that exact same thing like this. Okay, this is f of x plus g of x. Now it's important to remember that we're talking about functions, and that the f and the g are the names of the functions we're adding, and that the f and the g are not variables that you're plugging in for. The only variable is the x. There's only one variable, x. Okay, so difference, written in this notation, difference might look like, difference might look like this, f minus g. But difference could also be written as f of x minus g of x. Okay, the product can be written like this, fg, like f times g, or it can be written like this, okay, f of x times g of x, or f times g, both of x. And then the quotient can be written f over g of x, or f of x over g of x. Those mean the same thing. So let's look at an example of this. Okay, so for this example, we're going to let f of x be the function in blue here, 2x minus 1, and g of x be x squared plus x minus 2. So when they ask us for f plus g of x, we simply take the blue function, and then we add to it the green function, g of x. And then to get the final answer, we combine like terms. Okay. Now, let's do the subtraction here. F minus g. So again, we start with f because that's what's first here. Copy down f. And then we are subtracting g. Now, the only thing that's really tricky about this is that we have to subtract all of g. So we need to really think of this in parentheses because every part of g needs to be subtracted. Okay, so let's distribute this negative to all of g. So that gives me a negative x squared, a negative x, and a plus 2. All right, so now we can combine like terms, and we have negative x squared plus x plus 1. Now we have the two things multiplied together. Okay, so let's go ahead and distribute. I have to distribute the 2x to each part first. Now let's distribute the negative 1 to each part. And that's my answer for multiplying. Now let's try division. So I have f on top of g here. Let's just put the f on top of the g. Okay, and the only thing tricky here is that I need to factor that denominator to make sure that nothing cancels. Because if I factor this bottom one and I get another 2x minus 1 on the bottom, I might be able to cancel them out. So I'm going to blast from the past, pull out my backwards FOIL skills. X squared breaks down into x times x. 2 must be 2 times 1. And to get my inner term of negative x, positive x, I must have a plus 2 and a minus 1 because 2 minus 1 will give me positive 1, and 2 times negative 1 will give me negative 2. Okay, and it looks like now that I've factored that I don't have anything on the same on the top or the bottom, so it does not cancel. That's as simple as it can go, and so I'm done with that. All right, now let's talk about domain of the functions. When you're looking at a function and you're trying to find its domain, you should ask yourself, what x values can I plug into this function? because domain is about x values. Okay, so ask yourself, what values of x can I plug into this function? So that's what you're kind of thinking about. And then you're going to remember the shapes of your parent functions to kind of help you visualize what domain we might be talking about. So if it has an x squared in it, you might go, oh, that's a parabola. I know a little bit about parabolas. So you're going to remember the shapes of your parent functions. Okay, and then the next two things are what you're going to actually use to really do the math of deciding what the domain of the function is. All right, so when it comes to domain, there are two things that you need to look out for. The first is fractions. What do you know about fractions? You can never have a zero in the denominator of a fraction. So the first thing is, when you have a fraction in the problem, make sure that that denominator cannot be zero. Okay, so no zero in the denominator. And what you're going to do is you're going to take whatever that denominator is, equal 0. Okay, take the denominator and say that that denominator can't not equal 0, and then solve. You'll be able to figure out what the denominator can't be. All right, and the other thing that you have to look out for when you're trying to find the domain are roots, square roots. There's something that you cannot have with square roots, and that is you cannot have a negative underneath a radical. The reason for that is if you do have a negative underneath the radical, what you're going to get is a imaginary number. And we're just talking about real numbers on the real number line. When we start filling in that value of I, we have imaginary things. Those aren't a part of our solution set. So we're only talking about real numbers. The root cannot have a negative. So if you have a square root in the problem, then what you're going to do is you're going to take the piece that's underneath the square root and say that that part cannot be negative, it has to be positive. Whatever is under there has to be greater than or equal to 0. So when you're trying to define the domain, these are the two important things that you need to look for. Watch out for fractions. The denominator can't be 0. Watch out for roots. They can't be negative. Besides that, the domain is pretty much from negative infinity to infinity if there's nothing else that's stopping it that you're looking out for. So let's look at some examples of finding the domain. All right, so I'm looking at that. I'm asking myself, what values of x can I possibly plug into this function? Well, anything. You can plug in any x. I see an x squared, and that reminds me of my parent function. It must be a parabola. Well, I know that a parabola, the domain of a parabola is going to go from negative infinity to infinity. So, since there's no fractions and no roots, I look at it and I go, my domain must be from negative infinity to infinity. On this next one, I can see that I have a fraction. All right, so whenever I have a fraction, I remember that the denominator of a fraction cannot be 0. So what I need to do is take my denominator and say that denominator cannot equal 0. That's what I do whenever I have a fraction. Put the denominator to 0. Now, let's solve for x and see which numbers it can't be. In order to solve for x here, I need to factor this, and I already did that. Okay, so that means that I have two different things here. So that means that my domain cannot be -2 or 1. So I could say my domain is all real numbers except -2 or 1. But I want to write this in interval notation like I've been doing. So how can I write that in interval notation? I'm going to think of my number line. And my number line, I am cutting it into pieces at -2 and at 1. I have open circles where those points are not included. So that means my domain is going to have 3 parts. I'm going to have the part over here, which is from negative infinity to 2. Then I have the part that's inside here from 2 to 1. And then I have the part on the other side over here from 1 all the way to infinity. So that means that my domain has three parts: negative infinity to 2, union, joined together with, negative 2 to 1, joined together with 1 to infinity. All right, let's look at the next one. Since it has a square root, whenever I see square root, I remember that I cannot have a negative value under that square root. So what I'm going to do is take the part that's under there, and I'm going to say must be greater than 0. Okay, 3x plus 12 has to be greater than or equal to 0. So I solve for x, and I see that x has to be greater than or equal to 4. And looks like it can also be equal to negative 4, so I'm going to use a square bracket. And then lastly, if f of x is x plus 3, and g of x is the square root of x minus 2, what is the domain of f of x minus g of x? A combining of functions, we have to do f minus g. So let's do that first. Okay, and to find both of them together, what we have to do is find the domain of each one separately. So I'm going to find the domain of each part. And since I have a radical, I know that I cannot have a negative under the square root. So we're going to take this and say x plus 3 has to be greater than 0, as well as x minus 2 has to be greater than 0. So what values on a number line would be both greater than negative 3 and greater than 2? Well, the place where both of those overlap is right here. All of the values where x is greater than or equal to 2. Great, and that is the end of this lesson.